Hi everyone, welcome to today's session. So today we are going to dive into something called model performance, right? So before we discuss about the core topic, bias versus variance, we will start with understanding what is model performance. This is the one been talking for the last couple of weeks, right? Model performance. And today we will, once again continue with this term, the understanding this term model performance and some key concepts that every machine learning or data scientist practitioner must know. Okay. I'll just start with a simple question. So how do we know if a machine learning model is good or not? Very simple question. How do we know if a machine learning model is good or not? Yes, two correct answers. How do we know if a machine learning model is good or not? Yeah, two answers are correct. So who answered it? Yeah, Priya and Ramya answered it correctly. Very good. Okay. Is it something like, right? Let's say no, a model, just because a model works well on training data, does that mean it will perform well on a real world data? The next question is, what if the model is too simple or too complex? How do we find the right balance? How do you find the right balance between bias and variance? Okay. To answer these questions, what we'll do is we'll explore the model, what is model performance is all about, and what is bias and variance, and then we will understand what exactly overfitting and underfitting, and how to diagnose the overfitting, underfitting, and how to fix them. Okay, how to fix these issues. Okay, and finally we will jump into a live demo in Jupyter Notebook where we will see these concepts in action. Okay, let's get started. First thing first, what is a model performance? What is a model performance? Let's say I train my machine learning model. It works well on the training data. My accuracy is let's say 0.89 or 0.91. The accuracy is good with my training data set. Does that mean my model is doing good? So we need to find out the accuracy for the test data also. When you apply the trained model on the unseen data, it's nothing but the test data. What is the error? Okay, what is the test data accuracy? If the training accuracy and then the test accuracy is somewhat close by, then my model generalized well. Then my model generalized well. For example, in the case of linear regression or regression related problem, so we find out the training error. Okay, and training error, how well the model fits the training data. We find out, you remember, how many of you remember the mean squared error, root mean squared error, the training error, and similarly, we'll find out the testing error. I trained my model, machine learning model, using the historical data, that is a training data set. And once my model get trained, I need to apply the model on the unseen data. So for that purpose only we are training the model. We train the model with the past historical data with the combination of both the input features and the labeled out feature in the case of classification problem. And then we apply this trained model on the any real world new data to make a prediction. In the case of regression, we find out the training error. So after you train your model, what is the error? Root mean squared error. After you apply the train model on the unseen data, which means you make the prediction. What is the difference between actual and predicted? So that is what your prediction error, right? The error, right? So that is the error. So we call that as a test error. So if that error, the training error and test error somewhat close by, that means my model generalized very well. In the case of classification problem, we use metrics like accuracy, precision, recall, and FN score. Okay. Here, in the case of logistic regression or in the case of classification problem, what we do is we use log loss. the case of binary classification problem, we use something called log loss instead of finding out the error, actual minus predicted. So even the case of log loss, what we do is, for example, what is log loss? How does it works? Any data scientists are there in this call? How does what is a log loss? The difference between the actual and predicted. Here also the actual and predicted only. For example, customer A, B, C, and for him, we have something called the target labeled column is something like 0, 1, 0. That means this customer is going to churn. Churn means, what do you mean by churn? Churn means they are going to leave my business. They are no longer happy with my business due to various reasons. They want to leave my business. In the past, they left my business. And 1 second. So why you are not able to see my screen? Yeah. Okay. Okay, okay. You can refresh your screen and then you can see it, or probably you can log out and log in. Okay. So this is the this is called your actual. Let's for these three customers, this is the actual, and what is the predicted probability. For example, the predicted probability is 0.023, something like that. 0.541, 0.231, something like that. If you this is our actual class level, this is the predicted probability. If you subtract this one, whatever you get, that is your error. Okay, we can say that way also, right? This is error. If you are in the case of classification problem, if you are training log loss error and if your test log loss error is somewhat close by, or if your test log loss error is slightly lesser than your training log loss, that means your model is generalized very well. There will be a difference. Okay, I just write it here. This is the whole idea. To take any model, okay, machine learning model, this is the common thing, you should be knowing it. Well, so why do we have to train a model? You want to make a prediction. Like human, the models, machine learning models can also make mistakes. That is called your error, right? So what is the actual? You need to subtract the predicted values from your actual. That is what your error. So this is actual. Okay, this is called your error. Okay, error. So what we do is we train the model using the training data set, isn't it? So once you train your model, with this training data set, what is the error you need to find out, and then once you apply the model on the unseen data, when you apply this model on the unseen data, right, so you will get some actual and predicted value. Sorry, you will get the predicted value, right? So if you subtract that one, you will get error. So this is your test error. This is called your training error. Okay. If these two error are somewhat close by, then it is fine. But there are some cases the customers say, hey, you can use accuracy metrics, and my training accuracy is somewhat 0.89, and accuracy is my test accuracy is something like is equal to 0. Let's say 8 6 or something like that. These two are somewhat close by, not much variation, right? So these two are somewhat close. That means a model generalized well. What do you mean by generalized well? What do you mean by generalized? Model generalization is very much important. This is very important thing. You should remember it. Model generalization. Model should generalize very well. What does that mean? This is what it says. The training accuracy and test accuracy should be somewhat close by. Need not to be same. There will be some kind of variation, but it should not be too much a variation. For example, your training accuracy is 0.66, and sorry, your training accuracy is 0.89, and your test accuracy is 0.66. That means, your model overfitted. So that is called overfitting. Okay. So in the previous session, we discussed everything in detail, line by line. We discussed. I gave you a walkthrough about the churn prediction model. Okay, we discussed all the advanced concepts also as part of that. I demonstrated. So even this today's topic is also a little bit advanced one. Okay, hence please pay close attention here. So model generalization is very much important. This is what I discussed at the very first session when I explained about what is machine learning model. That time itself I discussed about this one. So when if you once you train your model and make sure that your model is generalized very well. What do you mean by generalized very well? Can someone tell me? I explained with various examples in the past. Simple analogies, start with simple interesting story, no? Simple story. For example, let's say, a student who prepares for an exam just by reading only the summary of each chapter. What is going to happen if a student he just reads only the summary of each chapter? What is going to happen? He can learn quickly the basic concepts, but don't you think he miss out the important details if he just read only the summary of each chapter? Yes. So when they take the exam, the real exam, right, they make a lot of mistakes, even on simple questions. Okay, so their answers will be consistently wrong, whether on practice test or the actual exam. This is what called as bias. Or, we can say the model is too simple. Model is too simple. Okay, makes wrong assumption. Your model makes wrong. And what do you mean by model is too simple? It means, right, the model misses patterns. For example, model trying to predict house prices using just only one rule. All houses cost 50 lakhs. That's very simple assumption, right? It ignores the important features like what is the square feet of the house, which location that house is there, how many number of rooms are there. These are the features, right? It missed out. It uses simply, only one rule. See, simple thing here in our day-to-day life. For example, if let's say if I ask you to give me the estimated housing price after 2 years. It's, if I buy 1.2 crore house in Bangalore, two-bedroom house in Bangalore, now for investment purpose, after 2 years, how much the prices can go high? So what are the factors that you will ask before you tell me the estimated price? The first question, what you will ask, right? Hey, can you please tell me the size of your house? Your house is two-bedroom, fine. What is the square feet? In which location it is there? How many number of bedrooms? You said, okay, fine. Already you said only two bedrooms. Are the living room is there? Yes. So these are the important factors that will influence the housing price. Rather than that, if you just train your model with only one feature, do you think that can give you the accurate estimated or predicted housing price? No. So this is called model is too simple. What happens is there are scenarios where you will miss out including the important features or the columns or the factors that are helpful in terms of estimating your target outcome variable, which is nothing but the housing price in this case. Right. So what will happen is if you don't include the important features, all the necessary features that are helpful in terms of predicting your housing price, obviously your estimation is not reliable. That is called, that is what so this kind of thing, right? We can say the model is too simple. In that case, what will happen is the model will perform poorly on both training and test data. Model will perform bad on both training and test data. The classic example is, for example, I have given you all the for the last 4 semesters, last 4 years, the fourth semester's question papers with answers to you. Okay. So in that case, you are you've gone through that everything fine. You are if I give you another practice exam, you are performing well. But if I in the case of actual exam, you're not performing well. Why? You did not understand all the questions. Maybe right, you have gone through only few questions papers only, not not more than 2 or 3 question papers because you need more knowledge to perform well. So in that case, right, both in the case of practice exam as well as the actual exam, you will not perform well. Correct? What is that? Who mentioned that Uday Kumar? This is my first class. Can I have papers again? What do you mean by papers? No, no, no. I'm just giving an example. Yeah, I did not give any questions. Okay, Uday Kumar, don't get confused. I'm just giving an example. Okay, I did not give any questions. Okay. Oh, this is the first class, right? Don't worry. We will share the. You can share your WhatsApp number or so in this chat. Okay. What we'll do is we will share the previous batches, previous sessions, videos. And guys, good news. Starting from this Monday, we are going to start a new batch. It is going to be alternative batch, okay? And every day from the scratch we will be covering it, okay? And the timings will let you know. Those of you want to join in the morning batch or evening batch, you let us know based on which we will accommodate. Okay, don't worry. Here, right? So to understand what is generalization, right? What is what is model performance, right? I'm just giving you some examples. Model performance is right something like how do we know whether my model performs well? My model should perform very well on both the training and test data set, which means I used some training data set to train my model. And then after I trained my model, I'm going to test my model with the training data set. Since I trained my model with the training data set, obviously the model, error will be less, right? The prediction error will be less. That is a common phenomenon. The test data set, I did not show it to my machine learning model. I did not show it at all. But though I did not show my test data to my machine learning model, when I apply the trained model on the test data, it should predict well. For that reason, I gave this analogy. Okay, I gave you 2 or 3 question papers with answers. You with that, right, you are preparing very well. And if I ask any questions related to that, you are able to give the answers correctly. But if I ask you some tricky questions, you get stuck. But whatever the questions I gave you in the past, there itself you have the answer. But when I just ask the question slightly in a different way or in a tricky way, you fail to answer that question. Though you have studied, you failed because you did not understand the subject thoroughly. You just memorized the same principle applicable when it comes to machine learning algorithms. If your model performs very well on the training data set, and if it is not performing well on the test data set, that is called your the overfitting. Your model just memorized like how we memorize it. There are students, right? They what they do is they thanks for sharing the numbers, Suhail Bokhari. Okay, fine. And others, very good. So in that case, what you need to do is right. You need to understand the subject thoroughly, and then only yeah. So only then, if I give any type of questions, you will be able to answer it correctly. You will think logically, and you will give the correct answer. If you don't understand, if you don't rationalize the topic, whatever we teach you, what will happen? You will not be able to answer it correctly. If you memorize everything, that is not going to be helpful. The same principle applicable when it comes to machine learning models. So we need to check after you train your model and you test your model's performance using the test data set. Your model accuracy is something like 0.91 or 0.89, which since it is close to 1, we say the model performance is good. Actually, what we need to do, right? We need to test both the model's performance with respect to the training and test data set. Training and test data set. For both the training and test data set, if my accuracy is almost close by, then we can say that the model generalized very well. This is the phenomenon, right? So that is, yeah, so that is what, that is when we call that as a generalization, model generalized very well. Okay. So model, what is model performance? Model performance is nothing but, okay, yeah, one second, somebody's, yeah. So the model performance, right? For example, right? So how do we know if our model is doing a good job? If somebody says, that's when the model performance comes in. So we evaluate it using the training and test data set. And the goal is not just to memorize the training data, but to generalize well on unseen data also. If I, if I apply trained model on any unseen data, should, still it should generalize very well because the tested data we did not show it to the machine learning model. The beauty of machine learning model is, as I told you earlier, so it learns the pattern from your historical training data set. Automatically, it learns the patterns. Once it learns all the patterns, now it is prediction ready. Now you can take your machine learning model and then you can apply it on any new data. For example, let's say you trained a machine learning model with the past historical data. Fine. Now I come back to you and ask you, hey, the square feet of my house is 1,208 and it is in the prime area of Chennai or Bangalore, and so and so area it is there. And the age of the house is just 3 years. Can you tell me what is the predicted or estimated housing price using your machine learning model? You said you already trained a sophisticated machine learning model. With the help of that machine learning model, why don't you give me the estimated housing price? Because I want to buy this house. I want to do an investment. What you do in that case? Since what you do is, you ask these basic information. So can you tell me what is the size of your house, square in terms of square feet, which area it is there, how old your house is? If I give these three information, you share it to your model, you show it to your model. Model will, as soon as it sees that data, it tells, hey, this is the estimated, this is the money that you can expect it may. Okay, so now the question is, whatever the price, estimated price given by your model, machine learning model, is correct or not? Is it accurate or not? The other example is stock price. You are investing money on Wipro share and the Infosys share. Let's assume that you retired. Okay, and after that is, as part of the retirement process, what they do, the final settlement they do it. You have only the final settlement money with you. Okay, so in this case, taking the risk is very, very difficult because it's a one-time money, right? So you cannot earn anymore with this big money. You want to be very cautious. You want to invest, but again, you want to make some, good money, attractive money with this money. Okay, retirement money. So what you do is, right, you want to invest money in buying some stocks. The share market, you want to buy some stocks, but before you buy that, you want to be cautious. Okay, you don't want to lose money. At the same time, even if you don't get profit, and even if you get wafer thin profit, let it be there. But I don't want to burn my big fingers, by losing the money, by investing too much money on this. Okay, so in that case, if my machine learning model predicts and tells, hey, for these shares, this is the expected return that you can get it. Let's 5% on each shares you will get the return. Okay. Next month, next month, when you sell it off, when you square it off, you will get 5% return or 8% return. So with that in belief, you are going to buy it because my machine learning model predicted the estimated return on investment, which is kind of okay for you. After investing the money and if you buy the shares, this is next month, the day when you are trying to square it off or sell it off, if the prices are not same as the way how my machine learning model predicted. The model predicted, you can get 8% return, but let's with that in mind, I bought this many number of shares. but let's say 1 month over now. So now I want to sell it off my shares, and but the share prices went down now. Instead of expecting 8% return, so 18% I could see a loss. That means the model prediction was not good. Model did not predict well. There are various reasons. Again, market dynamics, so many things. Other, let's say, everything is good. Market is doing good, everything. In spite of that, you are going to lose money. That means, your model accuracy is not good. So prediction accuracy should also be very, very good. Like, you go and contact some astrologer and he is going to tell, these are the things are going to happen in your life. What if the accuracy is wrong? What will happen? Right? So you are going to blame him. Similarly, right? That in that case, okay, but in the case of financial thing, if the accuracy is not good, you are going to lose huge money. So accuracy matters a lot. So before we deploy a trained machine learning model on the production system, we make sure that the model performance is up to the mark. The model is performing well on the trained data as well as the unseen data, which is nothing but the test data. Okay, so how do we evaluate using the error, right? So training error, how much am I getting? Test error. Some cases, what we do, right? In the case of classification, we use accuracy. I know. So what is my training accuracy and test accuracy? If they both of them are somewhat close by, oh, my model predicts well with the training data set as well as the tested data set, then we are good to go with deploying the model on the production system. Okay, so now right. So if when you apply your when you test your model with the training and test data set, if the errors or if the accuracies are somewhat close by, we conclude that my model generalizes very well. That means if you throw any data to my model, it can it can estimate or predict the outcome value with reasonably good accuracy. That means, right, model generalize well. Model generalization is very same example. The exam story I told you, right, a while back, the same thing is applicable here also. Okay. And next one is, right, so the next question is how do I measure my model performance? That is what I explained. You can use the root mean squared error in the case of linear regression. In the case of classification, problem, we use metrics like accuracy, precision, recall, FN score, and so on. So, what are the challenges that we pose it in general? So, either we're underfitting or overfitting. Like I said, like I told you a while back, the model is too simple. That means missing important patterns. You did not include adequate number of features, or you did not train your model with adequate number of data. In that case, you will end up with the landing into underfitting kind of situation. And there is another situation like overfitting. Model is too complex. Model is too complex. It memorized the training data instead of learning the patterns. Okay, it is not. So in this case, what happened? You included more number of features than required, more number of columns in your thing. The classic example is, as I told you a while back, to predict the housing price, what are the factors that are required? Size of the house, which means right the square feet of the house, and location, which area it is there. Other thing is like the age of the house. Age of the house also matters a lot, isn't it? My house is in the primary area, and I have the 1,600 square feet area is there, but it is a 40-year-old flat. What will happen? The price is not that good. So hence these factors are important: size of the house, area of the house, and age of the house. Okay, fine. This is fine. But if I include an additional factor, something like the color of the house, color of my bedroom, master bedroom, color of my other bedroom, study room. If I include these columns or the features in my machine learning model, right, to train it, so will that helpful in terms of predicting the housing price? Nobody cares what color of the house, all that. So all they care is what is the square feet and which area it is there, how old that house. These are the three important. And again, nowadays customers are very particular about parking lot. Do you have closed cover park lot is there? Okay. And do you have two cover parking lot is there. Okay, good. Based on that also the prices goes up. But in addition to that, if you say no color of the house, number of power points in the house, you have two more columns. Those columns are not helpful in terms of predicting your housing price. If you mindlessly include all the columns that are there, all the features that are there in your data set to train your model, what will happen is it can learn some the noise from the data. Net include train your machine learning model only with the features or the columns that are helpful in terms of predicting your target outcome variable. Blindly, if you just because my manager gave me data set which contains 25 columns or 30 columns, all the 30 columns blindly, if you go and train your model, what will happen is the model will learn noise. Like I said, the color of the house and number of power points are there in the house. These are not at all required to estimate the housing price, isn't it? Does housing price determined by the color of the house or the number of power points? No, right? It is up to the individual. The size of the square feet of the house and location and age of the house. These are the factors really helpful. These are the important features. Along with the important features, if you include some junk features also along with that, the model can perform well on your training data set. But when you apply this model on the unseen data, it will not perform well. Okay, it will not perform well. That is called your overfitting. I just write it here. Please, you can also take a note of it. This is my machine learning model. I trained this machine learning model using the training data. Okay. And when I apply this model, when I apply this trained model on the test data, okay, I can make a prediction. Okay. But with the training data, what is the error? Okay. Let's, my training data also contains the actual housing price. I just write it neatly. Actual housing price and predicted housing price. Okay. With the training data also, right? Once you train your model, you can take few houses data. Okay. For example, once one specific house's actual housing price was 1 crore, but my model predicted, one only, 96.5 lakhs predicted. So the difference between these two are called error. Okay. And similarly, the test data you take it because the test data you did not show it to your machine learning model, the trained machine learning model, because you use a different data. See, in the case of supervised machine learning model, before you train your machine learning model, you whatever the data given by your manager also, right? You split it into two different parts, train and test data set. The training data you will have, maybe right 75% of the original data given by your manager, you take it for training your machine learning model. Remaining unseen data, 25% of the data is unseen data. So what you do, right, you train your model with this 75% of the data, training data. And then what you do is, how well my model performs well with the training data set itself. For example, actual housing price 1 crore. And here now, let's, for the sake of simplicity, I make it 98 lakhs. Okay. So here maybe right. So 2 lakhs difference is there. Okay. And similarly, I'm going to take the same machine learning trained machine learning model and apply it on the test data set. And then what I do is again, I'm going to check what is the, the error here. Actual housing price, and then predicted housing price. My training data set, let's, here it says, 1 crore and here it says, 99 lakhs. So what is the error here? The training test data error is, how do you find out the test data error here? The actual minus predicted. So here 1 lakh is the error, right? The error is 1 lakh. Simple, yeah. Somebody tells you, hey, can you tell me if I buy this house, how much can I expect it? You say, 99 lakhs, man. But actually, right, after 2 months, you are able to sell it at the cost of 1 crore. Now you are saying that, hey, my friend told me 2 months back 99 lakhs, but now I made 1 crore. So what is the difference between the predicted and actual? 1 lakhs. That is error. The prediction error. Okay, prediction 1 lakh. And in this case, what is the error? 2 lakhs. Okay, 2 lakhs. Or let's 98.8 lakhs or something like that. So in that case, 1.2 lakhs. So the error, training error is 1.2 lakhs, and then the testing error is 1 lakh. Somewhat close by. That means, my model generalized very well. Even if you throw any data, my model predicts well with, good accuracy. The error is not much. Let's assume that. So so let's discuss about overfitting. When I apply the train model on the training data set itself, right? Let's here 1 crore is there, but my model, let's I just use some other color. This way, my model predicted the thing is 94 lakhs, but actual was 1 crore. And when I applied the, sorry, not 94, let's 99 lakhs. Let's 99 lakhs. And this is my training error. Sorry, my training error in this case is how much? Just 1 lakhs, right? 1 lakhs. Fine, my training is 1 lakh. So, and again, similarly, right, if you want to find out the test data, with the test data, if you apply the model, the actual price is 1 crore, but the predicted housing price was, 68 lakhs. So, what is the, this is my test error, right? My test error in this case, right? How much? Almost 42 lakhs. But here with my training data set, if I train when I check the error of my prediction error, right? So 99, we say no, very good man. The accuracy is really good. Just only 1 lakh difference is there. The error is very less. But you need to test it with the testing data also, test data set also. When you apply your model on the test data set, and if you compare the actual and predicted for your test data set, if the difference value, the error is too high, that means your model memorized. Your model did not generalize. Okay. So in that case, you need to address the overfitting issue. That is called overfitting. If your model is performing well on the training data set like this, and if it is not performing well on the test data set, that is called overfitting. That is called overfitting. This issue needs, this issue needs some treatment. We need to address it. Okay. Next one is underfitting. What is underfitting? Like I gave you another example. A student, he just studied only the summary of each chapter, for his exam. In the actual exam, he was not able to perform well. Even in the practice exam also, he was not doing well. Okay, that means, right, your model, your training error is also more and test error is also more. Training error is also more and test error is also more. That is what called as a underfitting. That means my model is not performing well on both the training and test data set. That is called underfitting because you did not include the adequate features or the columns in order to make a good prediction. So that is what you are underfitting. Okay, and next thing is, right, hope you understood what is training error and test error, and what is overfitting and underfitting. Okay, and we need to strike a good balance, right? So in this case, it should not overfit, it should not underfit. There should be a good balance. Okay, next one is the other important topic is bias and variance. Every data scientist should know what is bias and variance, right? So what is bias and variance? To understand why a model might not perform well, we need to look at the bias and variance. High bias means the model is too simple. That means the model is underfitting. High variance means it's too complex and memorized. We discussed about what is overfitting and unfitting, overfitting and underfitting, right? It's somewhat similar to this one. It'll somewhat similar to the bias is something like your um, model is too simple, underfitting. Model is too simple. Okay, model is too simple. Variance is kind of overfitting. Okay, that is what it tells us. I just tell you, give you a quick tip to remember this, the bias and variance. So bias is something like error. Okay, variance is also error. Okay, so in this case, what happened, right? This is you will this is something related to your underfitting. This is related to your overfitting. Overfitting is your model performs well on the training data set, but other data it is not performing well. That is what variance. Okay, the bias is underfitting. Your model is too simple. Here the model is overly complex. No, it's a complex model. This is simple model. Okay, simple model and a complex one. If your model is too simple, it may not be able to predict well because you did not teach your model with the adequate number of columns or the factors or the features. Like in the case of housing price, you just trained your model only with the size of the house. You did not train your model with the age of the house and then the location of the house. In that case, if you make any prediction with that overly trained model, it can lead to some kind of error, right? So that's called your underfitting. Too simple. Your model is too simple. But there are cases you included, so many features. You need to include the features that are really helpful in terms of predicting your target variable. Instead, you closed your eyes and included all the features that are available in data set. In that case, what will happen is your model will learn the noise also from this data set. Okay. So what is noise here? Okay, what do you mean by noise here? What is noise? Noise means something like junk, right? Noise means something like junk. You just remember that. In the case of machine learning, you can learn, hear these terms from the data. It's something like irrelevant details in your data. Noise is something like irrelevant details in your data. To predict the housing price, I need the important features like let's assume that, right? The important features like the size of the house, the area of the house, age of the house. But in addition, I have the color of the house and the number of power points that are there now. These are irrelevant. The three features are relevant, remaining two features are relevant. Just because you are including blindly all the five features, what will happen? Your model will perform well on the training data set, but when you show your model on the any unseen data, any new data, it will not perform well. So that is what is called as a variance, guys. Okay. That means the model perform well with some data, and some data it will not perform well. Let's say you trained your, let's say I have given you an assignment. Let's say I'm your manager. I gave you a task. Your task is you need to train a machine learning model. Okay, you trained your model and you come back to me. Who is that? What's his name? Let's Sushil and Uday Kumar. Both of them, they trained the machine learning model. Okay. They did a good job. They come back and tell me, sir, I completed the task, whatever you did, the memo. Okay, trained a model is okay. Did you test it? What is the accuracy of the model? If you say model accuracy is really good, the accuracy is almost 90 percentage. Okay, so can I believe it blindly or do I need to test it? Sushil or Uday Kumar, Velo. Velo, he did not give your number. He gave some fake number. Okay, fine. Difference between, yeah. So Uday Kumar, Conan, 99 point. So Uday Kumar says, my model is prediction accuracy is 99 percentage. Okay, what I will do is I will give you some test data. Now I'll ask you, Uday Kumar and Sushil, can you please, test your model on the data set, whatever I gave it to you, the new test data, and tell me how well your model performs. Let's assume that your whatever the data that you use to train your model, with that your accuracy is 99.9, like Uday Kumar said. But whatever the data I gave it to you, I'm challenging you. It will not be 99.9. Okay, why don't you test with my test data and tell me? When I give some test data, your model is not performing well. The model accuracy comes down. It's something like 78 percentage only. That means your model performs well with your data. With my data, your model was not performing well. That means that is what called as a overfitting. Got it? Correct, Uday Kumar, right? So you agreed. Okay, fine. But your model should perform well with high accuracy on your data and the whatever the data I gave it to you also. Similarly, when you publish your model on cloud, any people, the public, when they throw some data to your model, it should throw them back with the accurate predicted value. Then only they will be happy, isn't it? So if our model is performing well with your data and whatever data I gave it to you with that it is not performed, that is called overfitting. So underfitting is your model is neither performing well on your test data set itself and nor it is performing well on my data set also. Okay. So in that case, what will happen is that is called your underfitting because you did not include sufficient information. In simple, plain English, if you don't include sufficient information, you'll land up with something like underfitting. If you include, okay, more number of, the over information. Yeah, this is something like over information, under information. If you train your model with more number of features, which includes both the relevant and irrelevant, this is the man. This is the man is something like, you did not under information. You did not, include all the features that are really helpful in terms of predicting model. This is called your underfitting. So now you understood what is bias and, the variance and overfitting and underfitting. I told you bias is somewhat related to underfitting and variance is related to overfitting. And noise also I told you. What is a noise? Noise is something like randomness or irrelevant details in your data. That's the reason why it's very much important. Whatever the data that you use to train your model, your data is clean and you are going to include only the features that are really required. Okay. Next one is we will explore in detail what exactly the bias is all about. Okay. What is bias and what? The same example, let's a student who prepares for an exam by reading only the summary of each chapter and he ignores all details and formulas and examples. So what is going to happen is he is not able to perform well. He makes a lot of mistakes even in the practice exam as well as in the actual exam. So this is what we call high bias. It is also called as underfitting. So in this case, the model is too simple. It makes wrong assumptions and underfits the data. Okay, that is what bias. Bias is something like error, high error, because he did not study in depth the topics. Okay, and next one is what is variance? Variance is related to your overfitting. Okay, you prepared for the exam by memorizing the entire chapters word by word, or word for word. Okay, including examples. But you did not focus on understanding the topics. Okay, understanding you're not able to analyze, what that, the topics is talking about. Simply are memorizing it. Something like, student prepares for the exam, student prepares for the exam. 5 times they say, memorizing it, but they don't understand what that sentence says. Okay. So in that case, let's say you are a teacher, let's say you are the teacher, right? You gave four previous exams questions and answers to your students. In that case, what will happen is whatever the questions and whatever the answers you gave it in the past, Similar to that, if I give any questions, you are able to answer it well. But if I ask the questions slightly different, you are getting stuck because you can't apply your knowledge. The same principle is applicable in the case of machine learning model. In this case, the performance all over the place. What do you mean by that? Sometimes you are doing well, sometimes you are doing bad. Okay, this is high variance. The model is too complex, memorizing the training data instead of understanding the patterns. It performs well on training data, but it fails on the test data. Okay, low training error. Sometimes that low training error and high test error. So you will end up something like these are called the variance. And what are the takeaways now? So far, what we discussed. Okay, before that, let us look at this diagram. Okay, so what is this one says here? Okay, fine. The bias you understood. What is variance? We need to find a perfect balance between bias and variance to build a model so that it can generalize as well. This is an interview question, guys. They will ask you. Okay. So, what is bias? What is variance? You explained it. Correct. Bias is something like underfitting. High variance is called your overfitting. Fine. So, what is how do you deal with that in the case of real-time scenario? How do you find a balance between bias and high bias also problem, high variance also problem, low variance, high bias is also problem, and high bias, low variance is it's also a problem, right? That means a high error. Bias you just think is an error, okay? Variance is something like variation, okay? Higher, let's I give 10 different test data set. And if I ask you to test your model, I just write it here so that you will be able to understand very clearly. This is very important. That's the reason why I'm just writing it here also. For example, test data 1, test 2, test data 2, and test data 3. Let's say you have trained you built the machine learning model, okay, and your model is performing well on this. But when you apply your model on the test data set, your model prediction is not good. And your model, here it is not good. When I give another data set, it is kind of okay. It's kind of okay. Okay. That means, two test data set was not, that means, there is no consistency here. Variance is there, right? So there is a variance here. So here error is less. Here is also okay, not much error. But here, a lot of error is there. Your model accuracy is not that good. That means, variance is there. Variance is there. So in this case, the question is, here the error is kind of okay, but only these two test data set, my error is, more, right? Yes, but there is a variance. It should be consistent across all the test data set. Your model accuracy or your error should be less. Lesser the error, higher the accuracy. Okay. So in that case, for example, your error is slightly more, but, for all the four data set, it is performing well. Okay, that means let's let's say this way. Ideally, this is the expectation: low error. This is the expectation: low error, low variance. So for each tested data set, if I give it to you, your model should predict with higher accuracy. If the accuracy is less, that is your error. Okay, so error should be less. At the same time, all the test data set, the error should be somewhat, similar. It should not be low error. Okay. So that means low variance. So this is the ideal scenario that we are expecting it, but we are not living in the ideal world. Okay. There will be ups and downs. Okay. There are kind of situations. It's okay, right? So you need to find in that case, right? So how do I strike a right balance between the bias and variance? So error is nothing but bias and variance. Okay. So in this case, you need to identify the sweet spot. What do you mean by sweet spot here? So here in this case, the blue color one is your bias and the red color one is your variance. The total error is the dashed line. Okay. So here, as the model complexity keep increases, right? What will happen is your error is going down. That means you included more number of features. or factors. With that, my model can predict the housing price with the help of all the features. But what happens is the variance is going up. That means, right, some data set my model prediction is good, and some data set my model prediction is not good. Okay, here let's say in this case 14 people are there in today's session. Let's two people develop the machine learning model, and they test with remaining 10 students data set, different data set. Your model is performing well on some test data set, and some data set it is not performing well, right? So in that case, let's say you have included more number of features. When you included more number of factors in your model, what happens is the error is going down, but the variance is going up. So in that case, this is called your overfitting. Overfitting, right? Your model is trained well on the train to perform well on the training data set, but when you apply the model test data set, the error is going up. But so how do I strike a balance between bias and variance? So you need to find out the sweet spot. When look here, so when your model should not be overly complex. When you go from the left to right side, what happens? The complexity is increasing. So this is your error, right? This is your error in the y-axis. So here, what happens? In this case, the variance and both the bias at this point in time. For example, you included only eight or 10 features or 10 columns in your model. With that 10 columns, those 10 columns are really, really helpful in terms of predicting your housing price. In that case, what happens? With that 10 columns, your model variance also less and the error is also less, which means given any data, my model predicts reasonably good and the error is also less. So this is called your sweet spot. You need to find out the sweet spot, right? So until the bias and variance, right, where it intersects, okay? But when you increase the model complexity, obviously the error goes down, but the way it is not performing well on all the different data set. This is the issue. So you need to find out the sweet spot. One second. Okay, fine. So the what is the sweet spot? The point where the total error is minimum. If you see, this is where the error is minimum. Okay, this is the point where the total error. Here you have low enough bias, which means low error, and low enough variance. Okay, it is not underfitting, it is not overfitting. The ideal model complexity lies here. Okay, as we increase the model complexity, bias goes down, but variance goes up. We don't want that. What is our goal? Our goal is to find out the sweet spot where both are balanced. The bias and variance should be balanced. So that's where the total error is lowest. This is the model you want to deploy. Okay, you want to find out. Our goal is to find this sweet spot where both are balanced. Which one? The bias and variance. Now we understood what is bias, what is variance, and the bias is nothing but the error. Okay, it's error, and because your model is too simple, and the variance is the model is too complex. Okay, you need to try. Your model should not be too simple. It should not be too complex. It should be somewhere in between. Okay, so that it's something like a sweet spot. You need to find a sweet spot. Okay, it should not be overly simple, overly complex. It should be somewhere in between. So that is what we call as a sweet spot. That's how we balance it. Which one? The bias and variance. We are going to balance it. Okay, so to summarize, high bias is underfitting, the model is too simple. A high variance is overfitting, the model is too complex. And we need to find a balance between bias and variance to build a model that generalizes well. Okay. So that is what I have demonstrated as part of this visualization also. Okay. And okay, the next topic is